So let's begin with talking about what a statement is. A statement, or a proposition, is a sentence that has a truth value, meaning it is either true or it's false, but it can't be both. So some examples of statements are 2 plus 2 equals 4. That is always true. And 2 plus 4 equals 5. That is always false because 2 plus 4 is 6, not 5. And here are some examples of non-statements. He is a college student. We don't know who he is. He could be anyone. He could be my brother, who is a college student, but he could also be my dad, who is not a college student. So sometimes this sentence is true, sometimes this sentence is false, and so it's both, not always one or always the other, or rather always true or always false. It's not that. It can be both. So that's why this sentence is a non-statement. Another example is x plus y is greater than 0. We don't know what x is and we don't know what y is. X could be 1 and y could be 2. Okay, so 1 plus 2 is 3. 3 is indeed greater than 0. However, x could also be negative 1 and y could be negative 2. And negative 1 plus negative 2 is negative 3. And negative 3 is not greater than 0. So this expression could, sometimes be true, but it could also sometimes be false. So it's both, not always true or always false. Okay, so let's look at this question. It says, indicate which of the following sentences are statements. So we know that a statement is a sentence or expression that is either always true or always false, but it can't be both. So 5a says, 1024 is the smallest 4-digit number that is a perfect square. A perfect square is when you square any integer that is a perfect square. So let's say I have an integer x. X squared is a perfect square. For example, let's say x equals 2. So 2 squared equals 4. 4 is a perfect square. 3 squared equals 9. 9 is a perfect square. 4 squared equals 16. 16 is a perfect square. The sentence claims that 1024 is a perfect square. We can verify that by taking the square root of 1024, which equals 32. So 32 squared equals 1024. So 1024 is indeed a perfect square. Now it says 1024 is the smallest 4-digit number that is a perfect square. So we can check that by seeing the integers that are smaller than 32 and squaring that to see if there's any number that has 4 digits. So let's try 31. So 31 squared is equal to 961. That does not have 4 digits. So it must be that 32 squared is the smallest 4-digit number that is a perfect square. And this statement then is true and it's a statement because it's always true. Okay, so let's try 5b. She is a mathematics major. So we don't know who she is. She could be myself, who is a mathematics major, but she could also be my sister, who is in high school and is not majoring in anything. So this sentence can be both true or false depending on who she is. So it's a non-statement. Okay, let's try 5c now. 128 equals 2 to the 6th power. So we put 2 to the 6th power inside the calculator, we get 64. 64 is not equal to 128. So this sentence, this expression is always false. Okay, so let's try 5d now. X equals 2 to the 6th power. So we just saw that 2 to the 6th power is 64, and we don't know what x is. X could be 125. Okay, well 125 is not equal to 64, so that's false. But x could also be 64 itself, and 64 is equal to 64. True. So depending on what x is, this expression could either be false or true. So it's both. So therefore, this is also a non-statement.